Okay, I went through this whole entire thing of notes, got it all uploaded onto YouTube, and then deleted it. So we're gonna start again. So, welcome to our last section of new stuff we're gonna learn. It's all gonna be about rational exponents. This is what it means. You know what an exponent is? It's power. Rational numbers are numbers that can be written as fractions. So rational exponents are powers that are fractions. So it sounds scary. It's going to look a little scary. It's not going to be that bad. So hang in there. I'm uploading a set of notes so that you can go back and look at these without having to hear me talk at you the whole time. Of course, you can rewatch the video as much as you need to. And there's also something called a perfect squares and more paper that you will need, and I will kind of show you a little later. All right, so let's get started. Okay, first of all, you have to know how to read math and not sound like a moron. You have to sound like you know somewhat what you're talking about. So we've seen expressions like this. To read it, you say b to the nth power equals a. Remember that the number in the b spot is your base. And then whatever's in the n spot is your exponent. Now, it is directly related to this because powers and radicals are opposites of each other. Remember, they undo each other. So to read this, you would read it the nth root of a equals b. Now, the number on the ledge is called the index. The number that's underneath the radical sign, remember the radical sign is a little check mark. It's called the radicand. Remember the n is the index. Now, what I want you to notice, and later on this is going to become important, is that they all have the same letters, and they're related, and there's a pattern to it. Okay, so anything that can be written as a base to a power can also be written as a radical. So what acts as your base up here becomes the answer down here. Whatever is your exponent up here becomes the index here. And what was the answer here becomes your radicand here. So it's just a matter of paying attention to where they go, and they're related and they're opposites. It's kind of like saying 4 times 3 is 12. I can rewrite that as 12 divided by 4 is 3. Okay? Now, there are some situations when you are evaluating these. One is when your index is even, and the other is when your index is odd. Okay, so let's say you have a situation where you have an even index, 2, 4, 6, 8, whatever you come up with, and the radicand underneath the radical sign is positive. When that happens, you know that you're going to have two real roots as answers. Okay? It's kind of like when we take the square root of 4. You know that the square root of 4, when we're solving equations, is positive 2 and negative 2. It has two real roots. Okay? Now, we're going to have problems that look like this. The fourth root of 81 equals positive 3 and negative 3. Now, I want to show you how to come up with the 3 and the negative 3. When you're looking at a problem like this, this is where your perfect squares and more paper comes in. You take the index, okay? Go to your perfect squares paper. We had the x squared column filled out before, so now I have filled out more columns for you. Whoops, I don't know where that went. Okay. So we're looking at the fourth root, so I'm going to look under the x to the fourth column. And my radicand was 81. And then I go all the way to the left. That tells me what root is 3. Okay. Now, our other situation is when we have an even index, but the radicand is negative. Okay. This is like taking the square root of negative 4. And remember, whenever you had a negative under there, that's where your I showed up, your imaginary numbers. And remember, imaginary numbers are not real numbers. So since you only have imaginary answers, it means you have no real roots. You can't answer it. You can't do it. Your calculator is going to yell at you. It won't be on your chart. So let's say we have the fourth root of negative 81. Technically, the roots are positive 3i and negative 3i, but neither one of those is real. Okay, then our last situation is we have an even index of 0. That's always going to have one real root because the root of 0 is always 0. Okay, now we're going to look at what happens when our index is odd. First situation, you have an odd index and a positive radicand. You're going to get one real root, one answer. So let's say we have the fifth root of 32. Okay, so we go to our table. Fifth root, look under the x to the fifth. Find 32. Our root is 2. Now, because our 32 is positive, our 2 will be positive. So when we look at this situation with an odd index and a negative radicand, it's still going to have one real root. And this time our answer, the sign of the answer, will match the sign of the radicand. Okay, this is because when you multiply a negative number by itself an odd number of times, you're always going to have a negative left over, so you can have a negative answer. Okay, and then the odd root of 0, it's going to have one real root. It's always going to be 0. Okay, now I know that's kind of confusing. This is the way that we're going to use it right now. Okay, so they're going to give you an index 3 in this case, and a radicand negative 216. The first thing you have to do is rewrite it as the radical. So remember, your A goes underneath the little check mark, the radical sign, and the 3 goes on the ledge. Now we're going to analyze how many real roots is it going to have, which means we look at whether the index is odd or even, and whether the radicand is positive or negative. So now the last few slides we went over, so that when the index is odd, we're always going to have one real root. And that real root will match the sign of the radicand, so that root will be negative. Now, we have to go over to our perfect squares or more paper. We've got the third root, so we're going to look under our x cubed. Find 216. Come over, we get 6. So the answer is negative 6. Okay, next one. We got an index of 8, and our radicand is 256. So we're going to rewrite it. 8 on the ledge, 256 underneath. How many real roots? So we look at our index is positive, and our radicand is, our index is even, and our radicand is positive. So according to those two slides, means it's going to have 2 real roots. They're going to be positive and negative, one of each. Okay, so we go over to our x to the 8th on our table. And I look for 256. It gives me 2. So my answer is a positive 2 and a negative 2. Okay, now we have our index is 6 and our radicand is negative 4096. So we rewrite it. Okay, how many roots? It has an even index and a negative radicand. And when that happens, it has no real roots. So that means we can't evaluate it. You're done, as long as it's asking for real roots. If it's asking for any roots, then you could add the i's. Okay, last example. We've got our index is 5. Our radicand is 1024. Rewrite it as our radical. How many roots? Means we're looking at our odd index and our positive radicand. So it's going to have one root, and that root will be positive, just like the radicand. Okay, so now we're going to go over to our perfect squares and more table, and we're looking at x to the 5th. And I find 1024. It gives me 4. So my answer is 4. Okay, remember, rational exponents are any exponent in the form of a fraction. Now, this is the way it works. It's going to be a little bit confusing, okay? But remember when we learned about exponents, we learned that if you had x squared to the 3rd, that was the same as x to the 6th, because you would keep the base, multiply the exponents. So now, if I have a base, and then I have a rational exponent, okay, we have our power, and we have our index. means I can rewrite it this way. Because if I multiply 1 over n times m, I get m over n. So it's making use of this rule. Now, what happens is I take this and I rewrite it so that the n is my index. So my index, my base, and this top number is my power. It works the same way if you have a negative exponent, which you will run into. Okay, my n is my index, my b is my radicand, and the negative m is my power. So basically the way this breaks down is if you're given a problem like this, that top number is always the power, the bottom number of the exponent is always your index. If you're given a problem written this way, and you have to turn it the other way, the b is your base, this is the top of your fraction, this is the bottom of your fraction. Okay, so we are going to evaluate some expressions. So evaluating it means tell me what it equals. So the first thing we're going to do is we're going to rewrite 4 to the 5 halves as a radical. Okay, so the 4 goes underneath the radical. The 2 is my index. The top number is my power. So it's going to look like this. We're going to put the radical part in parentheses. And when you're evaluating, you're always going to start inside the parentheses. And you're going to use your table for this part. Now, you know what the square root of 4 is. When we're evaluating, we're not going to worry about whether it's got a positive and a negative. We're always just going to use just one answer. Okay? So the square root of 4 we know is 2. I'm going to write down 2. Carry the power over because I haven't used the power yet. Now you can go back to your table. Start with 2 on the left-hand side. Go all the way over to the x to the 5th column, and you'll see a number there. You'll see it's 32. That's your answer. Okay, now let's say we have 4 to the 2/5 power. First thing we're going to do is rewrite it. Now this time, the number outside the power will be 2. The index will be 5. Now, the 5th root of 4 is not on our table. So this you have to put in the calculator. To put it in the calculator, you're going to type in your index first, the 5. Don't know what happened there. Okay. Then you're going to hit your second button and the little caret button. And then you're going to type in the 4, the radicand. Okay, that's going to give you the answer 1.32. Carry the squared over because you haven't done anything with that. Put this in the calculator, you get 1.74. Okay, 9 to the negative 1/2. Let's first rewrite it as the square root of 9 to the negative 1 power. The negative always goes with the power, always goes on top. Never put a negative on this ledge here. You'll mess everything up. Okay, so inside parentheses, square root of 9 is 3. So now I have 3 to the negative 1 power. And remember, when you have a negative power, it means use the reciprocal of this base. So the reciprocal of 3 is 1 over 3. And then that 3 is to the first power, which we don't have to write down. Okay, 64 to the negative 2/3. First rewrite it. So I have the 3rd root of 64 to the negative 2. Go to your table. Under the x cubed column, find 64. Go all the way over to the left, and you find 4. So now I have 4 to the negative 2. Take the reciprocal of 4, which is 1/4. So I have 1 over 4 squared, which is the same as 1 over 16. Okay, that's the math you're going to be doing in assignment 10. There's a worksheet posted to do. Okay, so the next thing we're going to go over is how to actually enter this stuff into the Google form. Okay, so let's say we have this form here. Okay, I just took the last problems that we did, and I'm going to show you how to put them into the Google Doc. Now, the reason that we do the Google Doc is, 1, so that I can actually read what you've written, because some of the pictures were coming back really sketchy. 2, the benefit is if you're having trouble, you can get a hold of me. You can open up your document I can open up your document and we can both look at it in real time. We can make notes on it. We can talk to each other on it. We can both type on it so that it helps, kind of like us going over your actual handwritten paper together in person. Okay, so let's start with how to enter 4 to the 5 halves in math notation. All right, so you're going to go up to your toolbar here and hit Insert. Pick, hit Insert, pick the equation, and I'm going to hit my equals. Now I have to turn this into a radical with a power. So now I go to the equation toolbar, and I'm going to pick my x to the b, because I know it's going to end with a power. Then I'm going to go back to that toolbar, pick parentheses. Now I have to make my radical inside the parentheses. So I'm going to go back to that button, and this time I'm going to pick the one that has the radical with the A in the index spot. Okay, once I've hit that, you see the cursor is here in the index. Remember, my index is the bottom of the fraction, so I'm going to type in a 2. Now, the best way to move the cursor is hit your right arrow button. Okay, hit it once. Notice how my cursor is large and it's underneath the radical. So this is where I'm going to write my base, my 4. Okay, now hit your right arrow key again. Now my cursor is big, but it's still inside parentheses. I want it outside the parentheses. And now I want it to be the power, so I'm going to hit the right arrow key again. Now you can see that the cursor is little. I can put the power in. My power is 5. Okay, hit the right arrow key. So now my cursor is large. Hit equals. Now I'm going to work what's inside the parentheses, so that means I'm still going to have a number with the power. So go to your math toolbar, click the X to the B, and now I'm going to type in what the answer to the square root of 4 is, which is 2. Right arrow key, so now you can see the cursor is up above the 2. Put in my power. Right cursor, or right arrow over, equals, and then I can put, my final answer. I lost the paper, 32. There we go. Okay, we're going to practice this again. So I come down here to the next problem. Hit Insert, Equation, Equals. Okay, go to your math toolbar, hit X to the B, then hit parentheses, and go back to that toolbar and hit the radical with the A on the thing. Okay, so now I'm typing in the bottom of the fraction, which is 5. Right arrow key over. Now I have to type in my radicand, which is the base 4. Right arrow key over, then over again, and then over one more time, so my cursor is up. And now I put my power. Right arrow key over. And now I can start writing in the next step. Equals. Back to your math toolbar. Squared. Okay, I need the 5th root of 4. This is where you put it in your calculator. We got 1.32. Right arrow over. So I get my power, which is 2. Right arrow over. Equals. Put that in the calculator and I get 1.74. Okay, one more time. 9 to the negative 1/2. Hit Insert, Equation, then Equals. Math toolbar, X to the B. Math toolbar, parentheses. Math toolbar, radical. Okay, I'm going to type in my index, which is 2. Right arrow over. Type in my radicand, which is 9. Right arrow over. Right arrow over. Right arrow over. So now I'm up in my power at -1. Right arrow over equals. Up to your math toolbar. X to the b. Square root of 9 is 3. Right arrow over, -1. Right arrow over equals. Now, I have to use the reciprocal of 3. So up to my math toolbar, choose A over B, and 1 goes on top. On the bottom, use your math toolbar. The bottom is going to be to a power, so pick X to the B. So it'll be 3, right arrow over to the first. Okay. Right arrow over. Got a right arrow over again. So now you can see your cursor is normal sized. Hit equals. Back up to the math toolbar. A over B. So the top stays 1, and 3 to the first is 3. Is your final answer. Okay, now on this one where you had -1, you could have gone straight from 3 to the -1 to the 1/3, but I wanted to show you what the steps are in case you have -2 or -4, so you can figure out how to do that. Okay, now some of them you're going to have to know how to rewrite from a radical into the rational form. Okay, so you're going to start again next to the problem. Go up to Insert, hit Equation. Now, and hit equals. Now this is going to turn into a base and a power. So go up to your math toolbar, hit your X to the B, put in your base, which in this case is 25, right arrow over, so our cursor is up. Now, our exponent is going to be a fraction, so we have to go to our math toolbar and hit A over B. Now the top of our fraction is the power outside here. We don't see a power, so that means it's 1. Right arrow, now you can see the cursor is at the bottom of that fraction. Put in our index, which is 3. Okay, let's try that again. So we're going to hit Insert, Equation, equals, and then X to the B. Our base is 6, right arrow over. Now that we're in the exponent, go to the math toolbar, hit A over B. My power is my top number 2, right arrow over. My bottom number is my index 5. And you're done. Okay, it's going to take a little bit of practice. The assignment really isn't that hard. It's mostly trying to get used to using this program and how to put the things in. But remember, as always, get a hold of me if you have any questions, okay? And I'll talk to you later. Bye.